By the way, saying this, these certainly we know can set at least. MRI, I don't think anybody has made a saturate in 1D yet. Is this true?
1D.
Why can't you do this?
It's true, isn't it?
Yeah, it's true, but why can't you do this? Let's say people something weight, stable,
and it's continues to grow. That's really strange, right? But I think there's a problem with the shearing sheet, of course. You can always extract as much energy as you want at a finite rate, that is. And so you can always...
Yeah, because the linear phase never really terminates.
Yes.
I mean, there are no secondary instabilities that set in 1D.
That's probably...
Maybe that was the reason, yes, there are no secondary instabilities.
Well, even in Judy you start having acidic.
But it's not always the existence of nonlinear instabilities which limits. It's actually a mechanism which brings the system back to the marginal state. That's not what limits things. So the growth is being reduced. But for example, by lower magnetic field.
But not with the MRI, no?
Yes, with the MRI, the field of course is given.
I think you're right about it. That's the same with the Kelvin-Helmholtz instability, that it tries to get rid of the shear.
Kelvin-Helmholtz we don't mention here. Maybe. Well, I think we do, but
I think we do mention that.
I also think, but maybe only under 2D, of course. That makes sense.
3, 4.
There's 2D, by the way. Yeah, look. Here's Kelvin-Helmholtz. Here's Kelvin-Helmholtz. Streaming is pretty good. So these are all textbooks problems, and we can...
And we can also, what about Bailey Taylor?
Parker instability. Yes, sure. And then last, and then of course, Bailey Taylor and Parker.
All these stabilities we know.
Okay, you have setups for the Parker also. Who has the setup for Bailey Taylor?
Has anyone tried Bailey Taylor?
No. So then it's Toby. What else do we have?
Dynamo instability.
Yes. In
No.
fact, there's a kinematic Roberts flow dynamo. So that's a kinematic problem. But that is, of course, deliberately kept at a very simple level. So that means you can actually solve the equations by just giving a velocity field. So you actually don't. You have actually no hydro. You use hydro equals no hydro. You use density equals no density. By the way, in order to illustrate this concept, somebody was saying hydro is just the same as Navier-Stokes. Did you say that?
I did.
You did. And of course you can, it makes me smile that exactly you say this, because actually if I say hydro, I mean you can have hydro and no density, right?
Yes, true. Also no viscosity.
And that means, yeah, but if it's these,
Then it's not very visible.
then it's what? So these two together, of course, is Burgers. So you can do the Burgers equation in 3, 1, 2, and 3 dimensions.
If you want to be consistent, hydro should be called velocity.
Yes. That's true. It's an unusual sort somehow, but
It's just not.
yes. Yes. That's true.
Yeah, the velocity would be much better.
Oh, I'm looking forward to this. You can read it in full time today.
The same. At some point we did have I end instead of I end.
That was Wolfgang originally. That was Wolfgang originally.
What?
We have variables which are called IUU, that's the pointer which points in the array to this. You have the variable I, L, and rho. And of course you have the variable ISS, and you have the variable I, L, and T. Yeah. And of course previously this was called IN. You don't remember this? What? Process.
Entropy.
And
So then we get the day when I realized that you had renamed it.
but it was several of us. I think I was not alone. So we all made jokes of you, of course. Then Wolfgang will of course become very mad at us again.
That's why I decided to attend this hands-on meeting.
Yeah,
So
to
it's
make
more
sure.
difficult to make these jokes.
So now we can make jokes about Tony B again.
Yes.
All right. Now, we're running short of time, or what's the burden? We should. Yeah. So anyway, my hope is therefore that as many as possible, if not even all of you, can participate in this, regardless of the. I mean, there's no really requirement whether somebody has really participated significantly in development, but I think it's a requirement that people have worked with the code and done at least some modifications in the code. Right, and certainly it would be good. So, for example, Marcos had these interesting cylindrical quadro flow problems, of course. So you reproduce the existing results from the Barengi group, for example, and others. So that these are ideal examples, for example, especially when you can actually compare with other results in the literature. So, yeah, what are the comments on all of this, in addition to what you've done here? I mean, unfortunately, this may turn out to be the same state of the affairs in a year's time, of course, and we have to prevent this. I think the only way forward is by at least some of us making headwind here, showing, producing a few examples here. Once it has at least more than 0 examples, we should put that in some sense, in some force, in some way on the web page. And people can then, it's still open so that people can.
You should put us on CBS notification list.
But for this, no, not yet.
You should also do that, so
Yes.
that people get a sense of being in.
Yes, exactly. That's a good point. All right. Okay. What else do you have? I have certainly one item which has to do with the next meeting. But is there anything else we should discuss? I think
We actually discussed shock viscosity.
we have not, no. And
You
that's-
haven't?
No.
I think there was, I don't know what you had in mind here, the shock viscosity, Tobin Anders, it says.
Oh, you mean the shock, the high orders?
Yeah.
Oh, I
There's
see.
nothing I could do on that. I didn't do it.
I think somebody emailed me this.
Wasn't me.
Was not you? Yeah.
Well, I can briefly describe
Yes.
what's in there. So,
Stand up and.
so So just to which shock viscosity, what that actually is it's a viscosity that is proportional to the negative divergence of U, and so the expression is this. Well, this means that it's only the negative part that is actually taken. Yeah. So if this is negative, then the shock viscosity is positive. And if this is positive, then it's zero. Okay, now, and this you simply insert, here. So you then have, in your viscous force, you then have mu equals, where it goes to mu plus mu shock. And so there's shock.f90 in the Pensa code, and that calculates, because what's actually involved here is that you need to compute the diversion, so you need a little bit of information. You need information from the ghost stones there. Then you want to, you want to smooth it, because you actually have, because of this operator, you actually have situations like this, so like very sharp jumps. Yeah, where here's 0. So so that's going to lead to very inaccurate derivatives. And then what else? Smoothing. Oh, right. And then you also take the maximum of a neighboring grid surface, right? So if you have, if you know, if this is div u, or minus div u, and you have a very strongly peaked situation, then you compute, you smooth this over this, but you also smooth the neighboring point over the adjacent grid surface. Right? So it's even more smoothing, basically. Okay, so now each of these operations, the actual computation of the divergence, the smoothing, and taking the maximum over an adjacent grid, so it's all down to second order, which means that we can get away with 3 ghost stones. Yeah? So we start with computing the divergence, that reduces us to 2 ghost stones. Then we take the maximum of 1 ghost stone left, which we can do the smoothing. Okay, but this is all second order, and if you now, of course you have actually gradients in here, because we in the momentum equation, we actually, so plus other terms, and we actually write this out, which means that we have 2. This is part?
Yes.
And then get a couple of extra terms, but the thing is that you actually, the curl, the gradient nodula actually acts on nu. So you get derivatives of this shock viscosity. And I'm not too sure about it, but I guess since this is all computed to second order, and especially the smoothing is done to second order, I mean, across the 2 neighboring grid cells, but not more, a 6th order derivative may actually still be inaccurate. And so what I've done is to do all of this in 6th order, compute the divergence of u to 6th order, maybe using the standard derivative, then taking the maximum still over 1 adjacent grid cell, I think, but then again smooth over the full stencil, over 7 grid points. And it's implemented. It's very short. It's about 1/10 of the size of the original shock module, where there's lots of, I don't even know what it's, what that stuff
has
is
a
all
new
about.
name now, or what? Your thing has a new name?
Yeah, it's called shock_high order. And I'd be very happy if somebody tests this, because I've tested, there's actually an auto test checked in, I think. Can you check?
First of all, I want to see is shock.
Why would this be way shorter than the original shock?
Well, because there's just so much craft in the old one.
Because this is why the other module is so long.
It's so much additional stuff. You can, look at it.
You say
It's
smudge craft or smudge craft?
craft.
Oh, okay, yeah.
And I mean the other.
So,
There may be.
see if we can calculate the gradient of the shock viscosity. Do you do this on outside pencil? How do you do that?
No, I mean, shock is a variable in the shock coefficient. That's also a bit crazy. This thing is actually called new shock.
Yes.
So new shock is dimensionless, which is very counterintuitive.
Yeah,
I think this should be definitely called C shock, and this should be new shock.
Yes.
But you know,
But why?
Because it's
well, because this is a dimensionless coefficient, and new underscore shock means, I mean, sort of, this I would interpret as new subscript shock, where shock actually labels the, I mean, refers to this entire thing. I mean, new shock is the shock viscosity instead of the dimensionless coefficient in front of dx squared.
Toby, I tested your high order for very strong MRI with an improved speed. In the old days, first of all, it would crash all the time. And here, you was managed to just run until it was told not to run anymore. So it didn't crash. That was the first thing. So in the old days, it also...
Oh, sorry,
I haven't tried it. You mean this one?
No, it is big problem. Over before lunch, we talked about him running the shop.
Yes, that seems to be going okay.
See?
That seems to be going okay. But I have to stop it because I have to catch flight.
Ah.
That's the only reason. But it seems to be going okay. But were we using this one or the old shop?
The old, yes, it's the old. Anyway, sorry. But you said...
there's in 1D, test, you go to 1D test, and I think there's a, yeah, that one, SOD10 SHO. And if you run it, you can see that
So it's 400 points, it's a standard thing.
it's exactly the same as
But wait, this of
SOD10S.
course is also stuff we can really remove, right? This is complete junk here.
What is that?
There was, because there was one particular machine where somebody said, oh, we have to implement a special routine, which you all have to link to, a special library. If the machine crashed, it didn't turn off all the processes anymore. And so if somebody else wanted to run, then the machine was off, everything else was still running. So then he installed that was of course like 10 years ago, right? On this machine. And so we always have to link to this. But then you've written your general code, which always links to this, and you go to another machine, and such libraries of course don't exist. So we have to get our dummy libraries. What one? Can be all be removed, right?
Yeah.
But of course I don't do it. And even this one. Right? This we also don't need.
No, it's even wrong, it's LD underscore NPI.
And this is another thing.
Why
when
was
global
this
R
changed,
here?
by the way?
That's crazy, right?
Which test is that?
This is your shop test.
And by the way, I'm not sure whether it's actually educationally useful to have there's no gravity and everything there.
Not for a shop.
It's all by default, right? So obviously you don't have that.
So it may be okay to just do this, of course.
What about IOGs?
And no FFT and no power spectrum. Well, that's it. That's good enough, right?
I mean, a non-magnetic may make sense because in case it is natural to then add magnetic fields to that
I think
particular
for all
round.
by
but
the very
not on the others.
I saw that. And I've not saved it yet because I wanted to see.
And I think the canonical order would be the one in which we have the variance. So hydro first.
Okay, so then we run.
Okay. I think it makes some sense to try to see consistent there.
So we run this thing. So if people are not familiar with the tensor code here, you see how the practice works. So as I said, we first should always visualize what the hell is happening. So you find your IDL. Of course, I do always this here.
Yeah, but from one fish I change to engineer and this will be obsidian. So you can just enjoy it while it lasts.
Okay.
But what I was saying,
.rr is really den PC underscore read, where it reads the instructions more elegant.
so and what is this going to be a replacement by PC read var?
Yeah, it has all the functionality and 10 times more, and it reads into structures and reviews.
So, but what if I want to get X and U as not part of the structure? Because that's actually really nice, even though it's not good practice, programming practice.
Yeah.
So you know, I have to have bar.x and bar.y and bar.u.
That's what I mean, I think it's yeah.
So anyway, you see then that the entropy is higher than what the entropy here. Makes a positive jump, and the density makes a negative jump. That was the density here. Goes down. And it goes down by a factor of E, which means a factor of 10. I mean, log rho k down. Okay, so now we can run. And do we have the video file turn on or anything?
Not sure.
Doesn't even exist.
Really, the only thing I did is I copied.
So you only run in a video file here is this, or turn on of course. Like so. And then of course we don't know what is your bit time.
Oh, there is.
What?
Strange that it's set.
What? Yeah.
Strange that it's set.
Right.
It's set without.
And then you run. How long is it supposed to run?
It's going to stop soon.
And you see, oh, what the hell is this? Hold for 10, that's not. The first time I see such a junk here, I think there's something wrong. Maybe that's.
Is that your computer?
But how can you get a negative time?
Well, your computer has all sorts of problems with time, right?
How can you say such a thing in front of the camera?
No. Can you wind the tape back?
Can you, Axel, if you, can you run, there's a p-shock procedure.
You mean it works? Like just like this or what?
Yeah.
Do I need to read the data again? Or no? It does it do everything.
It does everything. Why does it take so long?
There it is undefined, okay.
Well, yeah, except it's broken. I haven't checked that in the fix. But it's very nice because it overplots the analytic solution and you actually see.
Okay, oh, that's how it looks like now. Okay. We do first of all t multi of 0, of course.
And the analytic solution, that's my routine, right? Because it takes ages to get that right. I had it almost right, and then
So what?
somebody else looked into getting
It has a slight negative.
Yeah, can you check whether the shock viscosity is actually, what the shock coefficient is?
You want to use too much, right?
Yes.
4.
Well, maybe, okay, but wait a minute, because, can you go in SOD underscore 10S and see what is, because that's exactly the same run with the, non-high order, oh, okay.
Okay. Anyway, you can.
So there's another thing. I'm using Gaussian smoothing, and Wolfgang said that binomial smoothing is actually usually preferable, and maybe that'll improve things further.
Which one is supposed to go in?
Binomial.
Uh-huh. That's almost the same. Yes. What else should we do? I can continue this a little bit later. I have to. Yeah. So that means we have treated this one. Yeah, what's the situation with stream boxes? Radiation transport in stream boxes. Anyway, we don't need to discuss everything. If you, I think one important item to be discussed at this late hour is maybe indeed what to do next and so. What do you think? Should we have another meeting of this time? Yes, Anna says. Question as well? Great.
Didn't Boris suggest to be a QED? How about January?
January? So that, I mean, it's a possibility. They have done this 3 times at Copenhagen, and twice in Copenhagen, once in Stockholm. And do it somewhere else, of course. But maybe we can also look into this. I mean, what are possibilities here? KMW is a possibility, Cambridge is a possibility,
I wouldn't do that job.
Ireland is a possibility.
Somewhere in Pacific.
So who's going to pay for this?
That's so obvious that it's over, has much to do with it. It's life, of course.